media posts and take interest in his writings. Dr. Subhash Kak is a Regents Professor at Oklahoma State University in Stillwater, USA. His research is on AI, quantum computing, archeoastronomy, and history of science. And he has also written extensively on the social impacts of AI. He is currently a member of Indian Prime Minister's Science, Technology, and Innovation Advisory Council. His most recent work is a theory that physical space has dimensionality of E, Euler's number, and he has used this to propose solution to the missing dark matter and dark energy problems. His work has been showcased in the popular media, including Discovery and History channels, PBS, public TV in Europe, and in several documentaries on science and art. He is the author of 30 books. He was awarded Padma Shri by the Government of India in the year 2019. Over to you, sir. We are eagerly waiting for your talk.
Thank you very much. I appreciate this invitation. I take it that can you tell me how much of time do I have to speak today? How
Sir,
long?
So it's a 30-minute session as you are.
Okay, fine. That's fine. Okay, 30-minute session. Thank you once again very much. And I got to hear the tail end of the previous talk, and it's very interesting to see all the advances that are taking place in quantum computing in India. Now, as for my talk, I was asked to speak on the larger questions of the interface between quantum computing and the motivating issues related to consciousness. And where does that come in? Well, one of the reasons why people started going into or trying to look at quantum computing was, well, the brain can do certain such things and the silicon machine cannot. And it's possibly because in the brain, you also have quantum computing. So if you could construct machines which are based on quantum computing, then you would have computing power which is beyond what the capacity of current day, say, AI machines is. Of course, when it comes to computers, they can do numerical calculations much better than human beings can, but they are not as good as at AI, although, as we all know, recent advances based on huge language models have created a situation, for example, use of ChatGPT, where we can really do things that we didn't know could be done before. So are we going to have the slides as well? Or if not, that's perfectly fine. I had sent in some slides. So what I'm going to do is talk just without the slides. And I looked at this question many years ago. The great American neuroscientist Carl Pribram in the 1990s, he held a conference and he wanted me to speak on what my views on all this were. And I wrote a paper which is, of course, available on the internet. It's called The Three Languages of the Brain: Associative, Reorganizational, and Quantum. So the point I was trying to make was that while computers deal with associative information, but the current computer model is not reorganizational. The brain is reorganizational based on what we do and based on what processing is done. The brain actually reorganizes its own architecture. Now, that is something beyond the Turing machine model. And therefore, this is something that we cannot see computers of the immediate future being able to do. And then, of course, I also argued that the brain also does quantum computing, and until such time all this is done together, we would fail to match the capacity of humans as far as cognitive processing is concerned. Now, subsequent to that, in the 1910s, I think it was 1915, sorry, not 19s, 2015 or so, 2016, DARPA in the US set up a committee, and they organized many week-long workshops at different places in the US and one in Cambridge. They invited people from different disciplines, including physics and computer science and neuroscience, and some of their own managers, to look at the question of when is it that computers will become conscious. So here, what I'm talking about once again is the interface of quantum computing and computing in general, and consciousness, because certainly consciousness is something which goes beyond what computers can do. And the question of why is the neuron machine conscious while the silicon machine is not, is of great consequence. So we met at many times, and what the ultimate conclusions of this committee, some of the leading scientists in the US and Europe, was that they were, well, it was sort of divided. Those who came from the algorithmic background, they thought that possibly computers will eventually become conscious, because once the complexity of interconnections within the hardware that we have of machines crosses a certain limit, then computers will become conscious. While the others, many of whom were from quantum computing area background, thought that computers will never become conscious. And the logic behind that was that the quantum computing paradigm is based on the intuition of or the interpretation of the many worlds interpretation, which looks at reality more as objects which are interconnected, while the more dominant and perhaps the deeper interpretation of quantum mechanics is the standard Copenhagen interpretation. And in the Copenhagen interpretation, consciousness and physical reality are two sides of the same thing. In other words, physical reality cannot explain consciousness. They're like two sides of the coin. Physical reality is one, consciousness, the observer is always away from the observed. And if you look at that perspective, then quantum computers will always fall short. And then there is another question to which I've given some thought, which is that in quantum computing, the error correction problem or the error correction systems that have been proposed work on logical bits. And the logical bits come after the qubits have been replicated, as in the very first circuit here, the encoding circuit, and then they are sent over the channel. But there's no thought that's been given to correction of the encoding process itself, because it's not quite clear how that can be done. Because as we know, in error correction, you need to have a reference, and therefore this, even if everything else was resolved, this would be a problem. And this I see as a big obstacle. And therefore, in my view, I'm a kind of a pessimist in the implementation of quantum computers. But of course, that doesn't mean that we shouldn't be doing this work, because the research on physics and other questions are going to have other payoffs. Now, let's go to the next slide, if we can. Yeah. So this is the difference between the Copenhagen interpretation and the many worlds interpretation. That in the CI, what we are dealing with is not the actual physical system, but rather our information about the system, which is very different from the MWI, the many worlds interpretation, where the whole idea is that we are looking at physical reality as it is. And this philosophical difference is something that one needs to keep on returning to, and perhaps in some sense, people who work on the violation of Bell's inequality, etc., and deeper implications of entanglement do. But this is something that's always a good corrective. The next slide, please. Okay, if the slide is not available, it's no problem. Now, what I have looked at recently is that perhaps we need to consider problem from an out-of-the-box perspective, and that might give us certain insight, which would help us in taking the quantum computing enterprise also further on. And the perspective that I've looked at is that of information or optimization of information. First of all, we know that nature is optimal, and so if we are looking at construction of quantum systems, perhaps the perspective of optimality would be helpful. Now, here, let's look at representation of information itself. Now, we can show, and it's a very straightforward mathematical theorem, that binary is not optimal and ternary is, if you're using logic. And in fact, in the 1970s, there were even efforts to create computers, classical computers based on ternary logic. They are somewhat more efficient than binary logic. And if ternary is more efficient, then possibly considering that question as well in the quantum computing projects may open up new space for further understanding or resolution of questions that were not quite clear earlier on. Now, it so turns out that if one's prepared to not stick to integer logic, then so this is the efficiency of coding, and the most efficient is E. Of course, it's not an integer. It's slightly more efficient than ternary, as you can see. In bits, it's 0.531 compared to 0.528. And as you see, binary, this is the table at the very end. Binary is 0.500. So binary is substantially less efficient than ternary, and E is optimal. So the whole question of what implications E might have, and one implication in the next slide is that it leads to, and this is not, we are not considering here actual representation, although that can also be done, but that's a deeper question. But here we are looking at it from some distance, the larger issues that arise out of it. And one implication of non-integer dimensionality, because here we are talking about dimension, binary dimension and ternary dimension, and E is non-integer dimensionality, is fractal behavior. And fractal behavior, as we see, as we know, shows up in all kinds of systems, in natural systems. And we are talking about the next page or next slide right now. So this is, of course, efficiency. And if you go further down, you'll see that this fractality shows up in all kind of nature, even in constants of physics. You find this fractality leads to, first of all, what's called the first digit phenomenon. If you look at natural numbers, you'll see that more natural numbers start with the digit 1, and that's more than those that start with digit 2. This is the first digit phenomenon. Probability of numbers starting with 1 is log 2, and starting with 2, this is the probabilities. 30%, 17%, 12%, 9%, etc., etc. And we see that these numbers are all over, fundamental physics constants, geomagnetic field, geomagnetic reversals, Fermi space, telescope fluxes, pulsar rotations, etc., etc. So this is something else also that one needs to look at, the first digit phenomenon, and see whether the way we are looking at physics problems or problem of quantum computing could benefit from this. Now, in last 2-3 years, I've gone back to the whole question of, yeah, and you can stick at this table, at this diagram for some time. I've looked at the whole problem of what if E is optimal, E is 2.718, can we say that space itself is E-dimensional, and of course our minds are 3-dimensional, or we see reality as 3-dimensional? Can we can that solve certain problems, and ultimately, of course, could that also be useful perspective in considering quantum computing itself? So considering and doing this, I've published a whole series of papers, and you can Google E-dimensional universe, and you'll find all these papers which have appeared in journals such as Scientific Reports, which is a Nature journal, and then including journals from India and Indian Journal of Physics, and journals in the United States. And I've shown that if one were to consider reality as E-dimensional, and our representation of it as 3-dimensional, then we can explain a lot of things. First of all, we can explain gravitation itself as a consequence of E-dimensionality, E-dimensional substrate, and this solves the problems of dark matter and dark energy. As we know right now, dark matter and dark energy, for which there is no lab evidence, are supposed to be 96% of the cosmos, 28% dark matter, 68% dark energy. Dark matter to explain the anomalous motions of stars and galaxies, and dark energy to explain the fact that a few billion years ago, the expansion of the universe started to accelerate. And for that, they postulated dark energy. So this is a total of 96%. And there's another 3.5%, which is the interstellar dust. So 99.5%. So current physics can only explain 0.5% of reality, showing using the view that reality is E-dimensional, and we perceive it through our senses and through our systems as 3-dimensional. We can solve all these problems. These problems get resolved, and the whole question of first of all, we don't need either dark matter and dark energy, for which, as I've already mentioned, there is no evidence. And then we also are able to show why about 4 billion years ago, the expansion of the universe started to accelerate, but in a few 100 million years, it will decelerate, and therefore the view that universe will not die a cold death, that this expansion will keep on going on forever and ever, that problem is resolved. Now, another problem on which a paper appeared just last week in the journal Theory in Biosciences, which takes the same view of reality as E-dimensional. I've looked at coding of biological information, and there is, as you know, all of modern sciences, maybe 90% of modern sciences after the 1960s are focused on biology, explanation of biological systems, medicine, everywhere is based on the genetic code, which was discovered in the 1960s. And we know how the 4 nucleotides of RNA, DNA and RNA are mapped into the 20 amino acids. And the codons are 3 units long. So 4 to the power 3 is 64. So there are 64 different arrangements of the nucleotide sequences, which are to be mapped into 20 amino acids. Now, if an engineer were given this task, they would say, well, for redundancy, let's assign three codons to each of the amino acids, because then each, this mapping will have equal error correction protection. But nature doesn't do it this way. And in fact, in nature, the mapping is, for some, there is no redundancy at all. One amino acid to each one codon, and for some there are six. There are certain amino acids for which there are six codons. So why should you have this extreme non-uniform coding, and for which there has been no solution at all for the last 60 years? And it's been assumed that maybe it's sort of random, and people have sort of tucked it away under the carpet, so to speak. So I've given a total solution to it using a-dimensional coding, and you can look it up on the internet. Just appeared last week, and we show that this e-dimensionality, which leads to fractal behavior, leads to a behavior where the distribution must be like, as you know, as I mentioned before, the first digit phenomenon, and that first digit phenomenon is also equivalent to, for those of you who know it, is Zeef distribution of languages, which is where if you look at any natural language and you look at the probability of different words, and you look at the word which is most likely, it has a certain probability, then the second most likely word in the entire language corpus or in a book will have a probability about 1/2 of the one which is most likely. The third most likely word would have a probability of 1/3 of the maximum, and so on, 1/4, 1/5, etc., etc. These are all long tail distributions. So I've been able to show that all this completely describes the non-uniform distribution that we have. So now, with this as background, what I would suggest would be interesting is, first of all, for all the researchers to explore these questions further or refute them. I have another more striking paper appearing later this month on the genetic code. So one that some of you might want to explore are implications of e-dimensionality. But this apart, as somebody who comes from India and who is who's also studied the Indian consciousness tradition, because right in the beginning I said one of the motivations for doing quantum computing was to explain the mystery of consciousness. And as we know, all the Indian sciences focus outside of those which look at the outside sciences, look at what is considered Atma Vidya. In fact, the Vedas themselves are Atma Vidya, and Atma Vidya means the science of consciousness. And there are a lot of lessons in the Indian tradition, and consciousness is perceived not as something which is emergent on physical system. If you look at all of Vedanta, and if you look at Vedanta from its core text, which is the Brahma Sutras and the Bhagavad Gita and the Upanishads, all the argumentation in Vedanta is that consciousness or the Atman is outside of the body. Atman is para, which means transcendent, which is quite consistent with the Copenhagen interpretation, and the logic behind that, as we know, is that the creator, one of the two creators of quantum mechanics, namely Erwin Schrödinger himself, is a Vedantin, and he, in his autobiography, claims that he was inspired by Vedantic ideas, consciousness as the observer being always outside of the physical system. So there are, in my view, and I've also written on it, also for the leading journal called the Journal of AI and Consciousness, where I've argued in papers, first of all, why consciousness cannot be physical. And therefore, this gives us a certain perspective where this could also be useful. First of all, now you might say, hey, how can this be brought into useful? Because isn't this a very general abstract idea? Well, and this is how I'm going to close my presentation. If physics and even quantum computing are at a stage where there are lots of obstacles, certainly physics has a crisis related to this 99.5% missing reality, for which postulates of dark matter and dark energy for which no evidence exists have been made. So how might physics be able to proceed further? And likewise, how could there be a breakthrough in the paradigm of quantum computing itself from where it's stuck right now? Well, in my view, the breakthrough would take place by bringing in the observer to a more central place. 1900 itself, if you look at relativity theory, the observer was given a more central place, and the speed of light was related to where the observer stands in relation to the physical system. And then the observer came in even further in the whole framework of quantum mechanics itself, because there is this divide between the observer and the observed. But since then, after the 1940s, there has been this attempt to explain physical reality in terms of objects alone, sort of pushing the observer to the background, as in the MWI, many worlds interpretation, which I think is limiting, and perhaps one needs to go back to CI, and we bring in the observer much more by bringing in entropy in a more fundamental way, because entropy represents something to do with observation, because it's a property of aggregates. It's not a property of an object. And I think that could be more productive. And in fact, my work on e-dimensionality itself is bringing this in some sense, because I can also tell you what the motivating factor or what the inspirational factor for all of this research was. 7 years ago, I translated the Kanada's Vaisheshik Sutras, and this is about 500 BCE, and it's very sad that Indian physicists don't read Kannada, because there's some brilliant stuff out there of use even now. In addition to 2 of the 3 Newton's laws of motion, it has a lot of other stuff, including discussion of observers, which you can read in my translation called Matter and Mind, which was published 6 or 7 years ago. Now, it has also almost verbatim representation of Newton's 3rd law of motion. In Sanskrit, Kannada says, karma, karya virodhi karma. To action, there is an equal and opposite reaction. Karma is reaction and karya is action. But what's interesting is that Kannada there says that, look, Akasha is real space, but they can call our space as our mind sees them. So he says they can call are a product of the mind, or manas, while Akasha is what reality is, one of the 5 Mahabhutas. So the intuition that took me to in this direction was that, well, physical reality is Akasha, which has a certain dimensionality, which is E, while how we represent it, which is in our minds, is 3-dimensional. So there is a separation, E to 3, which is what gives us a lot of possibilities. So if one can also do something similar in quantum computing, I don't know in what sense. I did write a paper a couple of years ago, which is in the Journal of AI and Consciousness, where I looked at the whole problem of neuroscience, and I applied this, and I was able to show that there would be 25 different cognitive agents within the brain. given what the size of the brain is, which is very interesting because using philosophy, we do know that at least the Sankhya system of philosophy that we have, one of the 6 darshanas, you have 25 tattvas. So there are lots of ways where all these threads are coming together, and there could be breakthrough ideas because these ideas have not been considered before, and they are based on sound mathematical logic. This E-dimensionality is based on a mathematical theorem that E is superior and E is optimal, and nature always follows optimality. In fact, for example, you can explain dynamics or physics itself using the idea of least action, which was done in the 19th century. So these are ideas which, it appears to me, can be very, very productive and can provide an edge and an advantage to people who are doing out-of-the-box stuff. And this is certainly an out-of-the-box thing with the potential which could help India perhaps go ahead of the others. So with this, I'll stop. Thank you very much. I don't know how much more time I have. If there is some more time, I'll be more than happy to respond to questions.
Thank you very much, sir, for your enlightening session. If there are any questions from the audience, please raise your hand. Yeah, so we have one question from Professor R.P.
How do you see the future of neuromorphic computing, which is getting quite mature, combining with quantum computing? Like, suppose you combine neuromorphic computing with quantum resources, single photon and single photon CPUs, along with neuromorphic computing. What do you see the future of that?
Well, certainly, if one can use resources much more efficiently, or quantum resources, and there's some stuff done, possibly. But as we also know, quantum resources meaning, well, you can access much more information if that's what you're looking at. Storage of information itself, as we know, is getting less and less expensive, and we see that in these deep language models, Chat GPT, etc. These things don't really cost very much. So that, but still, if you can bring in some quantum resource in some sense in a certain situation, maybe that would be helpful, and certainly worthy of further investigation.
Thank you, sir. Now, Director of C-DAC Kolkata and C-DAC. Sir, we have one more question.
Thank you so much, Professor Kak. It was a wonderful session and I learned so much. In fact, the theory that you have mentioned about observer and the thing that you are observing, Drashti Viveka, the Siddhant that we follow from, I think, from Bhagavad Gita as well, and one Upanishad, just forgetting. So I was also actually connecting these two dots, though I could not reach to that level where you have mentioned it beautifully. My thought process was, so if there is some other consciousness in our body, that we say that it is observing everything as a witness, and we are just AI sort of a thing. The body is just, you can think about an AI plugin which is managed, but this consciousness is different. Then where does it reside? Like how does it sustain? How do you consider it as a energy? How do you perceive it eventually?
Very, very good question. And the Vedic model or the Upanishadic model is that consciousness is transcendent. It's para. It's transcendent. It's not a product of the physical system. So consciousness is viewed as light. In Vedanta, or Kashmir Shaivism is also one aspect of Vedanta. Consciousness is called, in Bhagavad Gita, Maheshwara. Krishna says, I reside within each person as Maheshwara or Ishvara or Shiva. So Shiva is viewed as light. Consciousness is light. Our minds are where this light falls. So consciousness illuminates the contents of the mind. So we are all, consciousness is one, and Schrodinger also writes about it in his essay, What is Life? That for the average person, it's very difficult to understand how consciousness could be one, but in reality, consciousness is unity, which is what Vedanta is all about. Consciousness is unity, but our minds have multiplicity, because it's like the sun. There is only one sun, but the sun can fall into a million different pots of water, and that disk will shine there. So it's the same image, same idea, that consciousness is one, it's that light, which is why you have the statement, Shivoham, I am Shiva, which means I am that light. So the light falls into our into the brain, into the structures of the brain, illuminates that, and then there is this sense of self, of course. But the whole idea is, in fact, I have another paper, and you can Google it. It's right now as a preprint, where I argue using mathematical logic, and there are two theorems there, and the title of the paper is No-Go Theorems for Machine Consciousness. I argue that there can only be one consciousness, because if consciousness was a consequence of complexity, as a lot of people, computer scientists who are doing consciousness research in the West imagine, or some neuroscientists imagine, if it was a product only of complexity, that once the machine became more complex than a certain threshold, suddenly the machine became conscious, there is a contradiction, because then this complex system could be part of a larger complex system, which would also be conscious. And therefore, you would be confronted with the paradox of a conscious system within which there is another conscious system, which cannot be, which is logically impossible. And in fact, this is an argument which is very similar to the argument by many of the philosophers within the Vedantic tradition, that you cannot have nested consciousness. And therefore, there can only be in the entire universe one consciousness, because since the universe is governed by laws, in Sanskrit, of course, Rita, there are laws, there cannot be any scope for freedom of action. And that freedom, if at all there is freedom, that can be assigned only to the entire system, and which is certainly the idea that we have in the Vedic framework. So, to my mind, as someone who's looked at both these aspects, both from the neuroscience aspect of it, the quantum mechanics aspect of it, the computer science aspect of it, and examine the Vedantic tradition, both the standard Advaita Vedanta, as well as Kashmir Shaivism, which is also a Vedantic tradition, you find that it all hangs together. And it hangs together not only from the perspective of, okay, it gives us a good feeling, this is beautiful, that our tradition was so lovely, but I think more significantly, that it gives us an opportunity to make fundamental scientific contributions at this particular point in time, because science is confronted with fundamental crises, and these crises are emerging, having, the whole positivist perspective interpretation of quantum mechanics, which I think was beautiful by a lot of people in the West who raised in the object paradigm of reality, which is the Western traditions, came up with MWI and pushing MWI, and I think that has fundamental limitations, and that is what is led to the current crisis. So I think, as a scientist, to those of you, to others, to all of you as scientists, I think not just for philosophy, although that shouldn't be discounted, but for the ability to make real scientific advances from where we stand now, is an opportunity to bring in this perspective of the observer. We don't have to use the word Vedantin. Some people are very allergic to Sanskrit terms. So we can just bring in the observer. Let's bring in the observer. Let's bring in entropy. And once we do, or let's bring in optimal dimensionality. So we are only talking about mathematics. And this is the advantage that we obtain from there.
I'm just taking one more minute, sorry. But sir, so you claim that consciousness cannot be created.
That is the standard view. That's both the Vedanta view, and that's the paper which is under review in a journal right now. But you can read the arguments, and these are all mathematical theorems. And I also have a paper called "The Limits of Machine Consciousness," where I argue that consciousness cannot be created by any machine. And it's very simple, really. Let me give the argument in one sentence. If there was a machine in hardware and corresponding software, hardware can be mapped into software. So it's an algorithm. Just imagine, can you write an algorithm and suddenly that algorithm would become conscious? No, that's not possible. So because the hardware can be mapped into software. So ultimately, it's just an algorithm. A machine will never be conscious. And a lot of people, of course, in the West also, some of the leading guys, I know them, guys and gals, and people do recognize that this is indeed absolutely clear that machines will never be conscious. So, so to that extent, we are really aligning. People are aligning with the understanding and the arguments and discussions that have been a part of the Vedantic tradition. And in fact, I should also add that the whole question of the interaction of consciousness and the physical system, which my late friend, the great Indian physicist, George Sudarshan, in a paper in 1970s with his student, argued that you can influence the physical system by observation alone, which is called the quantum Zeno effect. And it's been demonstrated in the lab. You can actually steer a physical system simply by observation. And this is something which was done in the Vedantic tradition centuries ago, and it's called the Drishti Srishti Vada. The whole idea is, why do you need Shiva or Vishnu, or anybody, whatever you can conceive of, the deity, to control reality? Because reality is governed by laws, by rhythm, by laws. So the answer to that is that by drishti alone, srishti is done. And in mathematical terms, now you might say, well, these are obscure terms. We are scientists. In mathematics, well, you can steer probabilities without modifying the framework. Let's say the quantum mechanic framework, axiomatic framework, you have certain probabilities, but probabilities can be changed, which would change the dynamics of a physical system. So that's how you can relate mathematical framework and mathematical conceptions to this most outstanding, extraordinary insights that are a part of the Vedic tradition. Now, of course, a skeptic would say, how is it possible? We believe in progressivism. How is it possible? Well, all of our knowledge exists in our consciousness. And somebody who meditates or looks into one's own consciousness to the extent it is possible can access extraordinary knowledge. And that's also, of course, true in all creative tasks. Creativity cannot exist within the framework of knowledge because you're inside the box. All creativity requires your going outside of the box. And that outside of the box cannot occur when you are awake. And for that, you have, for example, in the Mandukya Upanishad, the whole idea that in the Swapna Avastha, that's where this Atman, because in the Swapna Avastha, you are not controlled by the physical living world, which constrains your consciousness. And all of creativity occurs either in dream, as in the famous story of Srinivas Ramanujan, who would see the formulas in his dreams, or in anybody, you are dozing off, you have a trance, there is a vision. it occurs, or even Roger Penrose when he speaks about how he got the idea of irregular tiles, the solution of the tiling problem. In every such creative task, it occurs sort of spontaneously, and that again ties up with our ideas of consciousness.
Thank you so much, sir. This is such a beautiful discussion. I can keep on asking questions, but we have limited time, so I'm stopping myself. You are really awesome. Thanks a lot. Thanks for all your messages and thank you, sir.
Thank you very much.
Sir, so now Shri Aditya Kumar Sinha, Director C-DAC Kolkata and C-DAC Patna, would like to thank you for the session.
Thank you, sir, for accepting our invitation. We have changed twice, but still you have agreed to deliver this talk. So very interesting, such a complex topic, sir. And I can tell you, sir, this was the one star attraction for the people to gather for this conference. This is the positive, sir. That I wanted to listen to you on this consciousness part. Sir, you have beautifully described about the various, like, you know, the various perspective, the wide spectrum perspective about right from Vedanta, Atmana, all those aspects and all. And you also have given this scientific dimensions and also talked about like it can be possible to have a upon this from a mathematical perspective. So these are some of the very important dimensions what we have. And being the country where these kind of things are being practiced in since years. And one thing I just came to my mind that many of such things are there in Indian scriptures and Vedic things and old manuscript and all. The first thing that we have to understand those scriptures are very difficult. So first thing we'd like to have to how can we simplify this? How can simplify this structure so that a common mind can understand that. So this is the one aspect is coming to our mind, and if you're able to understand those kind of writings, those kind of knowledge which has been created thousands and thousands of years ago, if we were able to understand, demystify those knowledge, those information, certainly we would like to progress more on this very complex topic, sir. And thank you once again, sir, for giving us a wonderful talk. And looking forward to have more mentorship, those who are interested to work in this particular domain. And I myself is also very much interested. I read twice the book written by Subhash Kak. I'm able to understand many of the such things. Maybe through this procedure, kind of the way we have talked today, we may have progress towards that. We will start reading more on that. Thank you once again, sir. Thank you for your time, sir. And I'm looking forward to meet you somewhere in person. Thank you, sir.
Thank you so much, sir. We also have one question in the chat box. So the question in the chat box is, how can we revive Kannada's realism?
Kannad.
How can we Kannad's knowledge?
Oh, well, please, this book, it's on Amazon.in. It's called Matter and Mind. I have the entire book translated. Just go and read it, and you can write on it, and whatever is valuable, it's absolutely incredible. Matter and Mind, Amazon.in, and I've kept it just 99 rupees, or it's free. You can download it for free. You know, for Atmanirbhar, you need Atma Vishwas. Have faith, Atma Vishwas. You don't have to necessarily be looking over your shoulder. Be confident, and these are amazing resources that we have, absolutely incomparable, extraordinary.
Thank you very much, sir. I hope that resolves all our queries. The participants were very much enthusiastic about this session. Now, moving forward with the program, I would like to